The Acorn Electron, or ALC, and the BBC Micro, BEEB, were two similar and yet simultaneously quite different machines. On a software and OS level, they were similar minus mostly the Mode 7 teletext mode of the BEEB and the lack of 3-channel simultaneous sound on the Electron. Both ran 6502 CPUs, both used BBC Basic and its built-in assembler, and despite some speed differences, a large amount of legally written software could run on both machines. Internally, of course, they differed massively in their form factors, and on a basic level, the Electron was a cut-down version of the BEEB. Notably, the BEEB has a huge array of expansion ports, and this enables it to connect to disk drives, printers, programmable robots, and everything else in between. The Electron, however, mostly later in its life cycle, did receive an array of hardware peripherals, and these were mostly designed to address these limitations. Further, the BEEB, containing a huge amount of dedicated chips, as opposed to the all-encompassing ULA, ran a great deal faster due to less bottlenecks. The ALC's design, for the record, squeezes 90% of the BEEB's functionality into just one ULA chip. But before we look at some of the more popular expansions for the ALC, let's first look at the BBC Micro's ports in order to see what we are up against. We have UHF out to the television, composite video out for green screen and amber monitors, RGB colour out for colour monitors, RS423 for serial communications, a cassette port, an analog port, a gap for an Ethernet connection, and underneath the machine from left to right we have the tube interface for coprocessors, the 1 MHz bus, a user port, a printer port, and a disk drive, and finally on the right we can also get a voltage out. So as can be seen clearly, a massive difference between the machines exists in the array of ports that the BBC donned and the severe cutting down in the Electron to basically just one unifying expansion port. However, I did mention earlier that a plethora of peripherals sought to address a lot of these limitations, and most of these, but not all, began with the most important one, the Acorn Plus One. The Acorn Plus One actually delivered 3 new ways to connect your machine to external devices through its output bus. The first, namely to printers via a parallel printer port, the second a 15-pin analog port for connecting joysticks, and most significantly it had 2 cartridge ports. This enabled, amongst other features, cartridges to be populated in the machine utilising ROMs and EPROMs. In effect, this was similar to the ROM sockets found inside of the BBC Micro. Pre-made cartridges could be purchased from Acorn Soft, enabling word processing and spreadsheet creation, along with a few games and ROM utilities. More significantly, however, this cartridge port could be used to communicate with disk drives, which was a feature previously lacking on the ALC, Mode 7 adapters, also a user port and a 1 MHz port, in addition to numerous others. More or less then, the humble ALC could be turned into a BBC Micro via these peripherals, although it must be stated, still with some limitations. Other notable hardware upgrades included something which I was lucky enough to get for my birthday, a Slugger speed and shadow RAM upgrade which involved modifying your machine internally. Talking of this Slugger upgrade, as a birthday present my father soldered the rather complex upgrade to my beloved Acorn Electron in 1988, and although it worked as stated, it didn't work on many games. That is to say, it didn't exactly simply improve speed of the games very much due to the fact that it wasn't akin to, say, a coprocessor grinding away, but simply took advantage of the fact that the ALC could read ROMs and RAM located outside of the ULA at its maximum clock speed of 2 MHz. On a standard machine, due to the ULA having to juggle between CPU requests and the needs of the video circuitry, coupled with a 4-bit RAM address as opposed to 8 on the BEEB, the overall speed of the ALK was significantly reduced. This device therefore sped up the machine by moving the lowest 8K of RAM outside of the reach of the ULA, and this is where most of the variables and the heavy hitting is done, and this enabled faster operation. This also explains some of the compatibility issues, as the speed increase would vary depending on what code was moving to the 8K special fast area. Still, it was a significant device, and in fact inspired by overcoming a limitation actually discovered by Acorn's own engineers. So now we have understood some of the limitations of the ALK when contrasted to its older cousin. I did mention, however, in my last video that many games, but not all, sooner or later were ported to the Electron by overcoming its limitations. But how on earth did they achieve this? Well, it's obviously beyond the scope of this series to document every trick and solution, but we can do a layman's summary just to get a feel. I'd like to stress at this point that all of the techniques we are going to look at didn't involve any hardware upgrades, so we'll get down to that in part 4 of this series. Thank you for watching.